Hi everyone, we meet again. Now we have finished the first two chapters of cloud computing, and today we will continue our course. In this chapter, we will talk about some network basics for cloud computing. Actually, in cloud computing field, the network consists of a variety of networking devices. In addition to the physical traditional network, there is also a kind of network. It is invisible. It runs inside the server. It is for the virtualized environment. In this chapter, we will cover the basic knowledge about the two types of networks. Now, when we finish this chapter, I hope you can achieve these objectives. The first is understand how physical and virtual switches work, and the second is understand the networking architecture used for virtualized environment. And the third is understand the traffic flow between VMs. The last is understand the concepts related to VLAN. Now, let's see the first subsection, network architecture for virtualization.
With computing virtualization, we can do CPU virtualization, memory virtualization, and I/O virtualization, and then create a virtual machine. After the virtual machine is created, communication between the virtual machines is required. Nowadays, if you can't communicate with the outside world, the virtual machine is obviously useless. So, how do virtual machines communicate with each other? All this chapter is mainly about solving this problem. First, let's take a look at the architecture of the network in this virtualization. The network architecture in most virtualization solutions is familiar. The bottom part is the physical server. The physical server is connected to the layer 2 switch. This layer 2 switch will be used as an access switch. Then, the layer 2 switch goes up to a layer 3 switch. The layer 3 switch can act as an aggregation switch or as a code switch. Then, the layer 3 switch goes up and it will connect to the router. If you ignore the firewall, or IDS, or IPS, and other security devices, the router will connect directly to the internet, which means that the router is an exit for the entire cloud data center. Next, let's take a look at the internal of the physical server. The main internal of the physical server are virtual machines. How does the virtual machine work with the network? There are two ways. First, let's take a look at the physical server below the leftmost cell. This way, the virtual machine's network card is directly connected to the physical server. The other way is that the virtual machine first connects its virtual network card to the virtual switch and then forwards the traffic through the virtual switch. The relationship between the virtual machine's network card and the virtual switch is also briefly listed below. The first relationship is to connect all the virtual machine's network card to the same virtual switch. The second relationship is that the virtual NIC of different virtual machines are connected to different virtual switch. There is also a third relationship, that is, if a virtual machine has multiple virtual network cards, each virtual network card can be connected to a different virtual switch. In a virtualized network, we divide all traffic into two types. One is east-west traffic, and another is north-south traffic. East-west traffic refers to the communication between the data center, such as the communication between the virtual machine and the virtual machine, and the virtual migration. All above are east-west traffic. The north-south traffic is mainly generated when the data center interacts with the outside of the data center. This slide shows some basic network concepts. The first one is broadcast and unicast. As the name suggests, broadcast is basically based on vocals. If your voice is not big enough, you can use a speaker. This broadcast can be heard by everyone in the same broadcast domain. If the person finds that the broadcast is looking for himself, then the person will return a message. If he finds the broadcast is not looking for himself, he will ignore the broadcast. This is called broadcast. After returning the news, the broadcaster and the person will establish a single line contact. Then the two persons can talk privately, just like you send me a message and I will send you a message back. This method is called unicast. Between broadcast and unicast, broadcast will bring a lot of problems. For example, safety. If a virtual machine is looking for B virtual machine, then it will broadcast to ask where is B. If the C virtual machine hears this message and it will reply to the message and the real B also replies this message. So it will get two messages and it has no idea about what to do next. This is a security issue. Another problem is efficiency. In the entire broadcast domain, A is looking for B. At the same time, B is looking for C, C is looking for A, and everyone is broadcasting. This affects efficiency. There are many broadcaster traffic in the entire network, and the real business traffic will be blocked. For this problem, we have a solution. Let's take a look at the VLAN in the bottom right corner. How does a VLAN do? It adds a VLAN ID to the head of each packet, which is an identification. If the VLAN ID is the same, it means that it is from the same broadcast domain. If the VLAN ID is different, that proves that it is from the different broadcasting domain. This broadcasting packet is not visible between different broadcasting domains. VLAN divided the interface of switches into two categories. One is access and another is trunk. Access is generally associated with the switch interface and the connect to the computer. However, the trunk is typically paired with an interface that is interconnected between the two switches. What does access do? Access allows only one VLAN to pass. It has a default VLAN. For example, the default VLAN is VLAN 2. When a packet comes over, it does not carry any VLAN ID. After this access port, access will give it a VLAN 2 tag. If there is a packet coming in, it carries the label of VLAN 2, which will strip the label of this VLAN 2 and then forward it. If you come over with a packet that is not a VLAN 2 tag, it will drop the packet. Trunk allows multiple VLANs to pass. For example, it allows VLAN 3, 4, 5. For example, it allows VLAN 3, 4, 5 to pass. If the packet is unlabeled, it will give a default label and then forward it. If it carries one of the VLAN labels of 3, 4, 5, it will be forwarded and without any modification. If the packet coming in is not the label of 3, 4, or 5, it will directly discard the packet. The port mode configuration requires a command to be tapped on the switch. The switch commands vary from vendor to vendor, but they are based on one same idea. That is, only 4096 VLANs can be created on each switch. Among them, VLAN 0 and VLAN 4095 cannot be used, and the remaining available VLANs are only 4094. After using the VLAN, the virtual machines in different VLAN cannot use broadcast to communicate. Do virtual machines still need to communicate with each other? Of course, yes. How should they communicate? This is our second basic concept, routing. What does routing work? For example, I have a correspondent on this side, and I want to communicate with 3 different virtual machines from different network segments. We call them ADC. Just like a room, this room has 3 doors, and 3 doors point to different destinations. What is the role of root? It tells you that you can find network segment A when you go out from the first gate, and you can find network segment B from the second gate, and you can find network segment C from the third gate. This is the role of routing. There is also a special case of routing. We call it default gateway, also known as default route or called the gateway alone. It works the same as routing and is also used to communicate across broadcast domain, but it's a different way. Imagine that routing is a room that has 3 doors in it. One door for the A network segment, one door for the B network segment, and the last door is for the C network segment. But the default gateway has only one door in this room. Whether it is A network segment, B network segment, or C network segment, or the extra D network segment, all goes out from this door.
Okay, everyone. Now we have finished the first subsection of this chapter. In this course, we have learned the network architecture for virtualization. And then I introduced some basic network concepts to you. These concepts are very important. You have to make it clear, such as what's the difference between broadcast and unicast? What is gateway and what is routine and what is VLAN? And then in next subsection, I will introduce physical network to you. Bye.